Today we're going to be focusing on the various properties. Now, one of the big suggestions I have is that you should definitely make flashcards or a Quizlet and such. It's not required, but it can definitely help you study because there are a lot of properties. And let's look at this one. So what I mean by a lot of properties is here's commutative property. Now, there's commutative property of addition and there's commutative property of multiplication. We are only focusing on addition and multiplication properties, okay? So what that means is that in a number sentence, like 2 plus 3 plus 4, this is all addition. We can also change this to say, okay, well, what if it's like 3 plus 4 plus 2? The reason they're equal to each other is because of this property. What is 2 plus 3? 5, good, plus 4? 9. Okay, so this is equal to 9. Well, let's do 3 plus 4, 7 plus 2, 9. So we actually end up with 9 equals 9. So these two sides are actually equal to each other. And the commutative property allows that to happen. So this is when the order of terms, right, each of the numbers, does not affect the sum. That means the order does not matter. And remember, sum is the answer to addition. So then the rule for multiplication is, well, this is the benefit of an iPad, I can do this. This does not affect the product because it's multiplication. So this is like saying 2 times 3 times 4. What is 2 times 3 times 4? Good, it is 24. Same thing if I were to do 4 times 3 times 2. It's the same thing. The algebra examples I'm not too focused on, but if you would like them just to kind of get your brains used to seeing letters, here you go. Just some examples. So the order does not matter. Let's try using the commutative property to write equivalent expressions. So this could be 60 plus 18. How can we adjust number 2? 7b plus negative 15a. And the reason I have the negative 15a in parentheses is because that negative sign and the addition sign are right next to each other. Otherwise, it would look like this. And that sometimes gets really confusing. But you can write it like that. It's not wrong. But sometimes it gets confusing for me. So I put it in parentheses. Go ahead and try number 3 and 4. You can pause the video here until you're ready for the answers. Okay, now that you've tried them, you can do negative 7 times 12. And for number 4, we have a couple different options. You could do 9 times 4x, but in between this 4 and the x is also multiplication. So you could have had x times 4 times 9, right? It looks a little odd, so we're going to leave it like this. But you have options here, and it will not change the answer. The next property is called associative property. What we're talking about is that how you associate, how you group the numbers does not affect the answer. This is the problem, this is the type of property that I like to call the copy-paste property. What I mean by that is the order literally does not change. The parentheses might move, the grouping might move, but the order of the numbers does not change from the left side of the equal sign to the right side of the equal sign. So this is when grouping of terms, again, does not affect, and this is for addition, so it should be sum. For multiplication, it's going to be the same thing, but it doesn't affect the product. So if I have 9 plus 1 plus 6, and I'm telling you, hey, I want you to do the 9 plus 1 first. Or I could have 9 plus 1 plus 6. I want you to do the 1 plus 6 first. So we move the parentheses from here, and then we're like, no, we're going to put it here. And the reason we can move it around is because everything is addition. So focus on this left side here. What is 9 plus 1? 10, good, plus 6. This is 16. Let's focus on the right side. What's 1 plus 6? 7 plus 9? 16. Good. So it does equal each other. What I mean by copy and paste and the literal order not changing is this. Look. 9, 1, 6. Okay, here's the equal sign. 9, 1, 6. It's as if you have to literally ignore the parentheses. You'd be like 9, 1, 6. Oh, the other side also has 9, 1, 6 in the same exact order. So the algebra, or algebraic version of this, would be as follows. For multiplication, there's a few different ways that you can write it. You can use your stars, you use your dots. Do not use X because, as you guys can see, we'll be using letters in algebra. All right. So let's try and write using the associative properties for 5, 6, 7, and 8. Go ahead and pause the video before you look for the answers. Now that you've tried 5, 6, 7, 8, check your answers here. You can pause the video if you need more time to look at the answers, or email and ask questions. So let's take a look at the next property, which is the next page. This is distributive property. Some of you might have done distributive property before, but this focuses on using only multiplication. It does not use addition when we're distributing. What I mean by distributing is if you have a highlighter, take out that bestie. You're going to highlight what is being distributed. So I see there's an A on the outside. This allows me to say A times B, which gives me that. But I can also send it, the A, to the C. It's kind of like grandma's on the outside and has all these cookies for the grandchildren on the inside. And it's like, okay, you get a bunch of cookies, you get a bunch of cookies. So the cookies are shared out, and you still keep your addition sign. Same thing for the second part. We're distributing A here. But in between, we actually see a subtraction sign, so make sure you bring over the subtraction sign. So this is actually your example for the algebraic part. Numerically, let's try this. Okay, what are we distributing? Good, we're distributing the 7. So what are we distributing the 7 to? We're sending it to the 5. There's a plus sign in between. Good, and then we're sending it to the 1. So you want to make sure everyone gets those cookies. So that's a step to help you simplify. But we're also just practicing the distributing part. We're not actually solving this. You could have solved it and gotten 42 as your answer, but that's okay. We're not worried about solving it. We're just practicing using distributive property. So go ahead and try numbers 9 through 14. Now be careful, numbers 12, 13, and 14 want you to undo the distributive property. So it actually wants you to find the GCF and then take it out, right? Kind of like divide out. So go ahead and try those. Pause the video here before you check your answers. All right, now that you've done that, here are the answers. If you are confused, let's look at problem number 12, like for numbers 12, 13, and 14. The GCF between 27 and 45 is 9. So 27 divided by 9 is 3, that's how I got the 3, and 45 divided by 9 is 5, that's how I got the 5. So if I were to go back and use the distributive property, 9 times 3 is 27, 9 times 5 is 45. So those are a little bit trickier, but our main focus should be numbers 9, 10, and 11. Now we'll get to some simpler problems. Again, if you want to pause the video here before we get to the next property, go ahead and do that. We'll get to some simpler properties. But because they're simple, they're also very easy to confuse. So identity property. Identity. That's kind of like you as a person, your identity, the value of you does not change. Right now, we're not going into pronouns or social constructs here. What we're talking about is your identity. The value of you does not change. So same thing for numbers. If I have 3, I want to add it to another number. What do you think I can add it to so the value of it doesn't change and I still get 3? If you thought of 0, that's perfect, because the identity property of addition is when we have the sum of 0 and a number is itself. But for multiplication, that's going to look a little different, because if I have 3, what can I multiply 3 to get the answer? We can multiply it to 1. So that is the difference, right? When we have the product of 1 and a number, you're going to get itself. So this is what I mean with the value of the number does not change. So this is the same thing as saying x plus 0 will give you x, or x times 1 gives you x. Multiplication property of 0 is another property where it's only multiplication. There's no property of addition property of 0, because technically that would just be identity property, because you're adding 0, but we already have that as identity property. So multiplication property of 0 is like what I like to call queen, top of the world, because 0 always wins. It's basically when you say that anything multiplied by 0 is 0. So 7 times 0 gives me 0. X, Y, Z times 0 gives me 0. Everything is multiplication in those problems. And then the last one, you might remember this from your fractions and your integer rules, but inverse property, for addition, we're talking about opposite. So it is the sum of a number and its opposite is 0. So if I'm taking 12, what is the opposite of 12? Good, negative 12. And if I add those together, I'm going to get 0. But for multiplication, it's the product of a number and its reciprocal. Fancy, fancy word. Remember from fractions, when you flip a fraction, that's the reciprocal. And that gives you 1. So if I have 3/4, what is the reciprocal, the flipped fraction of 3/4? Good, it's 4/3. If we multiply this across, we're going to get 12 over 12. If you simplify, you get 1 over 1, which is just 1. That's what inverse property does. It kind of allows us to cancel things out. You can use this next page to be able to give your examples. If you want to see the algebraic examples, I'm going to display it on the screen. You can pause it. But I would use this page to help you practice, like, ooh, what are some examples I can think of? So here's the top. If you want to pause it here to copy it down, you can do so. And then here's the bottom. So again, pause it if you want to so you can copy it down. Let's try and summarize this information. The commutative property. Blank of values does not matter. Order. Blank of values does not matter. The grouping, right? And if you want to make a hint here, right? Order matters, or order does not change. Kind of use this as a summary page. Identity property. The value of you doesn't change, good, so it stays the same. Try and think about inverse. What are we using? We can use good for addition, opposite. This is for addition. What's that word we said for multiplication? Good, reciprocal. property of 0 is when you multiply by 0, you get 0. Good. And what are we doing with distributive property? What's the operation? Yes, we're going to multiply a value to any expression inside the parentheses. Perfect. And you can think of examples here too. You're going to go ahead and practice with page 6. So go ahead and practice. Go ahead and pause the video before you're ready for the answers. Now that you've tried page 6, here are the answers. So here's the top of page 6. You can pause the video so you can check your answers. There we go. There's all of the answers. And then once you're ready, you can go ahead and try page 7.